When carrying out continual learning, validate updates as if they are new models or datasets. Does your model still work in the way you would expect? Why this principle? Continual learning introduces an attack vector for manipulating a model's behavior. In the past, systems that learn via unmonitored user interaction have been affected by malicious training data injection, e.g. Microsoft Tay. Once a model has been retrained, it is not the same as the old model and may well give quite different results, particularly on the edges of the old model's competence. It should therefore be treated as a new model. The principles in the development part of the life cycle, Section 2, highlight some key points that need to be considered when creating or developing a new model, including when gathering data. Testing processes should be in place to prevent external interactions having a negative effect on your model's behavior, and updates may need to be rigorously tested in the same way as the original model release. The extent of this testing should be chosen depending on the specific system and may be lower for local updates that would affect only a single instance of a model. Updates to your model and dataset should be validated, tracked, and documented in the same way as they are during your development process, outlined in Principles 2.2 and 2.5, Requirements and Development. Secure your supply chain and track your assets. This allows you to monitor for anomalous updates from continual learning manipulation. You will also be able to react to attacks, for example, by having the ability to roll back in the case of collecting poisoned or mislabeled data. This will help protect against the risks of malicious manipulation and continual forgetting, highlighted in Principle 4.1, in Operation, Design for Security. What are the goals of this principle? Updates made to your model and dataset throughout the operational life of an ML component are tracked in line with requirements established during their development. Updates to your model made from continual learning processes are identified and rectified if they are negatively affecting your model or compromising the integrity of your model's performance. You have mechanisms in place to identify new data that may have an adverse effect on your model. Strengthen your system. Design your architecture to ensure that certain performance targets are achieved before a newly updated continual learning model goes into production. Guidance. The process of creating CL models is likely to be automatic. It's important that this process only allows new models to enter operation when given parameters performance is met. As a part of your CL data collection and model retraining process, it's important to implement tracking and filtering of the data. Filters can be placed at checkpoints throughout the CL data collection process for sanitizing and cleaning incoming data. This can prevent your model being trained on data that is unwanted or deliberately malicious. Within the pipeline, consider introducing a standard set of transformations and augmentations that will standardize an input for model retraining. Specific transformations, augmentations, or dictionaries can be introduced over time to minimize new adversarial risks. Guidance. The filters that you require for sanitizing your CL data will depend on the application type, where you expect CL data to come from, and how much you can trust that source. Are they an authorized, vetted user? Example filters could include using hateful word detection in an NLP application, taking pixel values averages for images. What happens to collected data that is filtered out depends on the application and will likely need regular review by humans. Filters will also need regular review and may need updates if adversaries find ways to bypass them. Strengthen your approach, processes/development. Updates made to datasets and models during continual learning should be captured in their associated metadata created during the development stage of the lifecycle. Guidance. Creating associated metadata for an asset is discussed in Principle 2.5, Requirements and Development. Track your assets. Encourage manual, human testing of models and filtering of dataset updates. Your application and risk appetite will determine how often your CL updates require manual testing. This may be at each release of an updated, retrained model. Guidance. Where automated processes are used, consider using the tracked model metadata and parameters as an alert system. Significant divergence from the original or previous update of an asset may indicate anomalous or malicious behavior. When a metric diverges by a given amount, a process can be triggered to request human verification. During CL, you're collecting new data, and this should be treated as such. The same security concerns that are present during the gathering of data in the development stage are also present here. Guidance. The risks when gathering data are discussed in Principle 2.2, Requirements and Development. Secure your supply chain. Apply the same principles during CL. It's especially important to think about how much you can trust your data source. Are they trusted users of a system, or can anyone provide new data points?